Hi, this is Hannah. I'm working for the CS245 Programming Languages class at Bryn College, fall semester 2014, and today I'll be talking a little bit about the programming language Logo. The programming language Logo was created in 1967 by Daniel Balbro, Wally Ferzig, Seymour Papert, and Cynthia Solomon at Bolt, Baranek, and Newman, BBN, a research firm in Cambridge, Massachusetts. By the 1980s, several dialects of Logo had been created, among them Apple Logo, Krell Logo, TRS-80 Color Logo, Terrapin Logo, TI Logo, and others. Now, UCB Logo, or Berkeley Logo, is considered the most standard dialect. After its initial creation, Seymour Papert used Logo and turtle graphics as a means to explore his own ideas about computer science education, but the language of Logo itself does not require turtle graphics. It is its own language. Turtle graphics could be thought of as a drawing library for Logo that allows for a particular learning paradigm, which will be discussed later. Using turtle graphic commands, a robot, or a turtle represented on a virtual canvas, can be moved around a plane. This turtle has a location, orientation, and other properties about its drawing pen, which it drags around as it moves. These properties include line width, color, and whether the pen is up off the plane or drawing down on the plane or canvas. These are a few art pieces which can be created with turtle graphics commands. Broken ice, paving, and triple helix. Seymour Papert, a mathematician and computer scientist, researcher, and professor at MIT, was a strong proponent of the constructionist education style. In this style, learning is discovery-based, and students are meant to explore and build on their own knowledge from knowledge they have previously gained. In 1980, he published the book Mindstorms: Children, Computers, and Powerful Ideas, in which he describes his own views on computer science pedagogy and the use of turtle graphics with the computer language Logo. Papert used turtle graphics and Logo to teach programming and geometry. Instead of telling students how to do something, he encouraged them to engage in something called turtle talk. This was a method of thinking through problems and creating solutions in a mechanical or algorithmic manner. The learner was asked to place themselves in the position of the turtle, and then to move about a space as they would like the turtle to move. As they did so, they would narrate what they were doing and then be able to translate this process into an algorithm. For example, if a student wanted the turtle to draw a circle, they might start by walking forward a bit, turning right a bit, walking forward some more, then turning, etc. They might then come to the conclusion that they would need to repeat this a number of times before the turtle came back to where it originally started. Teaching students a mechanical thinking style helps them to program and to recognize the difference between algorithmic and non-algorithmic approaches, and the learner is able to apply this method of thinking to other situations as needed. In addition, the use of turtles and playing turtles allows the learner to use their own sense and knowledge about their body and to relate to the process of programming on a more personal level. This style of learning uses body syntonic reasoning. I would like to share two quotes from the book Mindstorms by Papert with you. First, even the simplest turtle work can open new opportunities for sharpening one's thinking about thinking. Programming the turtle starts by making one reflect on how one does oneself what one would like the turtle to do. Thus, teaching the turtle to act or to think can lead one to reflect on one's own actions and thinking. People are capable of learning like rats in mazes, but the process is slow and primitive. We can learn more and more quickly by taking conscious control of the learning process, articulating and analyzing our behavior. These two quotes really show how for Papert, thinking about how we think is just as important as the thinking itself. First, I'd like to go over some of the concrete syntax and jargon of the Logo programming language. First of all, Parameters to procedures are called input, and the return values from procedures are called output. A procedure that produces an output is an operation, while a procedure that has no output is a command. For example, the print procedure is a command because it produces no output. Simply prints something to the console. A predicate is a special type of operation whose only possible outputs are either true or false. There are two data types in the Logo programming language. First is the word. A word is a string of characters that evaluates to itself. If the word is a string of characters that is in a number format, then they evaluate to a number. And if it's a string of characters that's simply just a string of characters like alphabetic characters, then that evaluates as a string. They are preceded by a double quote. The other kind of data type in Logo is a list. Lists are marked by the square brackets, and they can contain words, lists, or lists and words. A list which contains only words is called a sentence. Variables are simply a word that is attached to another Logo word or list, and its value can be accessed by using the colon. So here we have a short code snippet in which we create a variable called x, assign the value 3 to it, print its value, and then use the value of x to do a multiplication and print the product of that multiplication. Here is an example of what a predicate looks like. Remember that a predicate is an operation which returns only true or false. Here is an example of the predicate empty p. Now, it is common practice for predicates to end with the p letter at the end of their name. So, empty p is a predicate which returns true if the given list is empty and false otherwise. So now, here we have a statement, print empty p list hello world, and it will print 0 since the list is not empty. The Logo programming language has a variety of iteration commands, but for the sake of brevity, I'll just show you a few on this slide. First, we have the repeat procedure. The repeat procedure takes in two inputs. The first is an integer and the second is a list of commands. The repeat procedure will execute the second input, which is a list of commands, for the first input number of times. Next, we have the while procedure. The while procedure also takes two inputs. The first is a condition and the second is a list of commands. And the while procedure will execute this list of commands as long as the condition remains true. The for loop is like many for loops in other languages. This for loop takes two inputs. The first input is a list containing 3 to 4 values. The first value is the name of the variable which will be iterated. The second value is the starting value which that variable is initialized to. The third variable is the value at which will stop the loop once the variable has reached that value. Now this is inclusive. And the last value, which is optional, is the step. So you could have a for loop that increments the variable by 1 or by 2 or 3 or however many you like. Now the second input is another list of commands, and these are the commands that are executed for every iteration of the for loop. Procedures. So the syntax for procedures is quite simple. First we have the word to followed by the procedure name, and then we can have a list or a sequence of commands and statements, etc. And finally, we're going to end this with the word end. And to call this procedure, we simply use the name. And there's no parentheses, you just like type in the name. So in this example, greet, we just have the procedure print hello. So it doesn't return anything, it just prints hello to the console. Now let's say we want to have input in the procedure. So in this example, we have a new procedure called personal greeting, and it's going to take in a parameter or input called salutation. And so instead of just printing hello, it will print whatever parameter or input is passed to it. So when we call this new procedure, we're going to call it by its name, personal greeting, and then we're going to give it a input, a word in this case, which is quote, hey. And then this is what will be printed to the console. Next, we have an example of procedures that produce output, or an operation. So here we have a procedure called square. And what square does, it's going to take an input value n and output n times n. So here, we're printing the output of square with an input of 5. And what this will give us is 25 printed to the console. Logo also has conditionals like if and if else. Here we have an example that uses if else. Now, the if else command takes in 3 inputs: a condition, a list of commands to execute if that condition is true, and a list of commands to execute if that condition is false. Here we have it in use in a procedure called factorial. So factorial is going to take in a number called n. If n is less than or equal to 1, it will output 1. If n is not less than or equal to 1, we'll output n times the factorial of n minus 1. And so this is like a common procedure that you see, recursive procedure that you see in many languages written in Logo. Okay, hi everyone. I thought that since we've already gone over some of the Logo syntax, I'd show you guys how Logo works in combination with turtle graphics. So first I'm going to go over a couple of the things that we just talked about, just like simple things. So like let's try printing out a sentence. So we have print, and then we're going to make a list. Hello world. We can do that, and when you have words in a list, you don't have to precede each word by double quote. We can clear the console, and then let's try using repeat. So let's try repeat 3, and what do we want repeated? Let's just say print hi. Yay! Okay, so now that's done, let's, I guess, start using some turtle stuff. So the triangle that we see at the center of the screen is our turtle. The pointiest part of it is where it's facing. So if we go forward 100, we will see that it goes forward 100, dragging its little pen behind it. Let's say we want to go right to the right by 45 degrees, we can do that. And then maybe after we go right, let's go forward some. And then let's see where we are. Okay, now, what can we do with that? Let's go right again. And then let's go right. And now we're horizontal again. And maybe we'll do a forward 50. So this is just like playing around, seeing what we can get. And let's just do like, I don't know. left 90. And basically we're just doing some scribbles. But the point is, that's just how you do some basic commands, and then CS will clear your screen. So I wanted to show that. Now let's say we want to make a square. So first, we think about how we would make a square. So like if we're doing turtle talk, then we think, okay, we'll go forward by a some amount, and then we're going to turn at a 90-degree angle, and we'll go forward and then turn, and then forward and then turn. So I'm just going to do something like that. So forward 100, and then we're going to turn right by 90, and then go forward again, and then go right by 90, and forward, and then right, and forward. And let's see how that goes. And we have a square. Yay. But instead of writing all that out, we could use a lovely repeat. So let's try that. We'll clear the screen, we'll clear the console, and let's make a square using repeat. So we'll try repeat for forward 100, right 90. Let's make it bigger this time, 200. Now for a bigger square. Okay, so we have that, but what if we want to make a function? So let's make a square function that takes in a side length. So we remember that we declare functions with 2, and we have square, and we're going to give it a side length. And basically we're just going to go forward by that length, and right by 90. And we're going to want to repeat this 4 times. And we can, I guess, indent that so it looks nicer. And then we're going to close that with an end. And we'll clear the screen, and let's make a couple squares. So square, we'll make a tiny square. And then we'll turn the turtle around right 45. And then we'll make a bigger square. And let's see what that looks like. Cool. So first, in the right here, we have our tiny 100 square, and then we turn 45 degrees right, and then we made a bigger 200 by 200 square. So that's pretty cool. That's just some basic stuff, but there are some nicer designs you can make, obviously. So I'm going to show you guys that next. These are some really cool programs that I just found online. It's not mess around with them too much, but as you can see, you can come up with some really cool designs with really a minimal amount of code. And I'm going to run that a little bit more slowly so you can see kind of what's going on here. So we have, in the code, we have several nested loops. You can see like that repeat. And so yeah, so this is like pretty cool looking. I'm going to stop that because there's some other cool stuff to show you guys. A snowflake, a Kosh snowflake. I'm just going to run it really fast. Yeah, but there's like all kinds of cool things you can make with these turtle graphics, and a lot more complicated and prettier stuff if you want to get all involved with the colors and such. Alright, so now for a little bit about the implementation. I looked at PyLogo, which is an implementation of Logo based on the UC Berkeley logo written in Python, mostly by Ian Bicking. It's dynamically scoped, which means that So like, as opposed to lexically scoped like scheme is. So in scheme, we have lexically scoped, which means that within some kind of function or closure, if there are variables, those variables, when the function is called, the variables values are the values that they had when the closure was created, as opposed to whatever the values are at the current time. And so in this implementation, it's dynamically scoped, which means that those variables, if they're in a function, are going to be whatever value they are currently in, like current in the global like program. It does not matter what they were when the function was created, because closures aren't really a thing. So so that's what I looked at. There's a couple special forms. The makes, which are basically the makes and local makes, which are assignments. The to, which is something that which we've looked at before, which creates functions. I looked a lot at the code for this, like all of the source codes online, and there's a lot of code, let me tell you, like thousands of lines of code. I read through a lot of it. I managed to get the tokenizer Lexer part working like by itself from all of this mess. So I was able to get like lines of code to be broken up as they were supposed to be. But then, like from this point, when I needed to kind of pass these into the interpreter to get them evaluated, I kind of got really lost in all the code and just very confusing. But I just wanted to show you a little bit of the code anyways. I thought this part was interesting. Just like imagine you have a stream of these tokens, and like if you see that one of the tokens is a semicolon, then you can just keep skipping all of the tokens until you get to a new line, because that means that everything following the semicolon is of course comments, and we can just skip the comments. So so that was just like something that like we could pick out from the interpreter. Some pros and cons of Logo. Pros are definitely it's very simple, easy to learn. I think for a new student, this would be a great language to start someone off on, especially when putting to use turtle graphics. Like definitely kind of similar to, I think the approach and having it be so practically based is really similar to how we teach the intro CS class at Bryn, and how like we can see the practical application of the coding through this art that we produce. But specifically with the turtle graphics, you are also getting this body syntonic kind of learning style that I talked about at the beginning of the presentation, where you're putting yourself in like the mind of the turtle and thinking through each step, like, okay, well I need to go forward, now I need to go right, and like really thinking through exactly what you want to draw and thinking through what steps algorithmically you need to do to get that to happen. And I think that like process of learning how to think through things algorithmically is really important for people who are learning how to program. And so that's definitely one of the pros of Logo and using Logo with turtle graphics. One of the cons definitely is that like it doesn't seem like you'd be able to create complex data structures like objects, since we're mostly limited to the words and lists. So that would be definitely a con. Some sources which I would like to thank for helping me with this presentation. Definitely Papere's own book, Mindstorms. Very enlightening and It was a pretty fun read, so I definitely recommend it. Thanks all for listening. I hope you enjoyed.